In this short video, we'll use Harold's EAM module to simulate the absorption spectrum and refractive index spectrum as a function of reverse bias values. So we've already created the epitaxial layer structure with the quantum well in red in the center of the layer here. And then for the EAM simulation, there's a special simulator node, unlike used previously with the Harold XY and Harold 1D and 2D simulations. When I click the Start button, Harold will solve the Poisson drift diffusion, Schrödinger model, excitation, and electric permittivity models. And then I'll be able to inspect the results. So for example, with the Poisson tab, we can plot, for example, as a function of bias values, which we have here, we can plot the change in the electron band edge. So each line on the graph represents a different bias value, and you can see how the band edge changes with bias. And similarly, on the Schrödinger tab, we can look at the various wave functions that have been calculated. On the final tab here, we can plot as a function of bias a graph of the various spectra that we're interested in. For example, on the x-axis, let's put wavelength, and then let's look at the absorption spectrum for both TE and TM polarizations. And there we have TE, you can see on the y-axis labeled TE, and TM absorption 1/centimeter as a function of wavelength. Similarly, the electric permittivity, very similar data, just now we're looking at the electric permittivity. And the same for refractive index, for example.